Good afternoon to all viewers. We are here from the Nehru Planetarium, Nehru Memorial Museum and Library, and in collaboration with the Public Outreach Committee, Astronomical Society of India, we want to bring the planet Venus closer to you. And in this endeavor, we have very eminent astronomers and chemistry scientists are going to join us, and then we are also going to be joined. Professor Sujan Sen Gupta is with us. Tripti Kumari is with us. Professor Sujan Sen Gupta is from Indian Institute of Astrophysics, Bangalore. Tripti Kumari is from Gagi College, where she teaches chemistry, and she has enormous enthusiasm for astronomy, and we have been doing several sessions with us. Professor Sujan Sen Gupta, he is the expert from India on studies in connection with planets around stars other than the Sun, the exoplanets. His ideas of using polarization signatures for the studies of exoplanets is being used by Jet Propulsion Laboratory and California Institute of Technology to study and understand clouds around extrasolar planets. So we welcome you, Professor Sujan Sen Gupta, and we welcome you, Tripti. It's lovely to have both of you here with us. And
Thank you, Ratna, and good afternoon to everybody who is watching.
Good afternoon, sir. Good afternoon. It's an absolute pleasure to have you, sir. I just heard about you from Ratna, ma'am.
And I'm just addressing the children now. This is just to tell you that take full advantage of this. We have experts here with us who can tell you about. Right now, Professor Sujan Sen Gupta from all the way from exoplanets, he's going to come and tell us about the planet Venus. And any chemistry questions you have, ask Tripti ma'am. And we are going to be joined by other researchers in the planet Venus also. There is one very exciting surprise. I'll tell you that later. I just wanted to tell all you children that use this to post your questions. Professor Sujan Sen Gupta is here specially to answer your questions. You have to put chat questions. But remember, don't put just hi, hello. Huh? And so you ask your questions about planet Venus or about anything to do with astronomy. All right. So we are going to do that, and maybe just a few comments from Professor Sujan Sen Gupta to tell the students what is the current excitement. Why are we here for this?
Are you going to show any video or anything before that about Venus?
Yes. I was planning to, in fact, tell some of the children who may not know initially how to look at Venus in the sky and a little bit about it. But before that, I just wanted to place in perspective that there is this excitement, which is why we are meeting here. The excitement being the detection of phosphine in the atmosphere of Venus. And maybe if you could just tell a few words to the children about that, why we are all gathered here, the current excitement.
Okay, I may take some 10 minutes to explain all the things there.
Please.
Okay, so good afternoon, everybody, and welcome to this. So, in 1 September of 1967, famous astronomer Carl Sagan predicted that there could be life in Venus floating in its atmosphere. So, in another September 2020, a group of astronomers has announced something which is taken by media. I think you all have heard in media, life discovered or signature of life discovered, or more precisely, possible signature of life discovered in Venus. But what the group of astronomers has discovered really? So they have reported the discovery of traces of some chemical or compound known as phosphine. But what is the great deal of that? Phosphine is also discovered in Jupiter and Saturn, date back to 1974. So at that time, we didn't make any noise that then life should be there in Jupiter and Saturn. So why now suddenly we are telling that in Venus, phosphine means there could be life? So for that, we need to know a little bit about what is this phosphine. So phosphine has a boiling point of minus 88 degrees centigrade. That means under natural condition, it is always a gas. It is a colorless gas. It has a garlic-like or a rotten fish-like smell. And we know that one atom of phosphorus and two atoms of hydrogen. When combines, it gives rise to phosphine. But it is very easy to say that when two atoms of hydrogen combines with one atom of phosphorus gives phosphine. It takes enormous amount of energy to combine these three atoms together to form this molecule. It needs at least 550 degrees Celsius temperature and tremendous pressure to make this combination. Now in Venus and Saturn, what happened, this phosphine is formed deep inside where the temperature is very high, above 550 Celsius, and the temperature is very high. Then this phosphine comes out to the surface through the convection. What is convection? It is just like when a water is boiling in a container. So the water droplet comes out, and then the cooler one goes down, like there is a circulation. So the similar convection is happening in Jupiter and Saturn. So through this convection, phosphine comes to the surface. But as soon as phosphine comes to a region cooler than 550 Celsius, it gets oxidized with the water. So then how can we see phosphine in Jupiter and Saturn? No, because this circulation is so fast, this mixing rate is so fast that the chemical reaction rate cannot overtake it. So as soon means before the phosphine become oxide, more phosphine comes from the deeper region, and because of that we see it. Now we should have seen phosphine in Uranus and Neptune also, but there this circulation is quite slower. So the chemical reaction is faster than this circulation. Now coming to the Earth. In Earth atmosphere also we find phosphine. Now phosphine could have been formed deep inside Earth's surface, but it cannot come out from the solid surface of Earth because Earth has a solid surface. It may come out little amount through volcanoes, but then immediately it get oxidized because Earth has a oxygen rich atmosphere. But then how this phosphine comes? Now phosphine in Earth comes through two process. One is by the industrial procedure, that is we the human being creating the appropriate temperature and pressure creates this phosphine, which is a very inflammable object. Whenever it comes into touch with oxygen, it burns. Otherwise it is produced by some type of bacteria in the air. This bacteria, it is not known which particular bacteria dissociates the organic molecules and produces this phosphine. So in Earth, the presence of phosphorus is purely biological, either by the intelligent life like us or by the very primitive one cell bacteria that is producing us. In any case, this is by life. So this is in Earth, it works as a biosignature because phosphine cannot produced chemically on Earth. If it is produced, it will be immediately get oxidized. So now let us jump to the Venus. So the group of astronomers, they have reported traces of this phosphine in the atmosphere or in the cloud of Venus. Now how much this is the trace? It is very little amount, just 20 molecule per 1 billion molecules in the atmosphere. This is present, and this is 50 kilometer above the surface. And now we know that because of a runaway greenhouse effect, the surface temperature, the mean surface temperature of Venus is about 460 degrees Celsius, much less than 550 degrees Celsius. And the surface at the surface, the atmospheric pressure is about 90 times higher than that of Earth. So this is not sufficient for phosphine to be produced chemically. So these astronomers have checked in all way that whether in volcanoes it can come out or everything, but they could not match that there is any known chemical channels through which this phosphine can be produced. So now comparing with the Earth situation, they have come into some possibilities that since we do not know any chemical channels that is possible under the condition prevailing in Venus, it may be possible that this phosphine is produced by bacteria. Now, there are two sides of this. First of all, we do not know if there is any unknown chemical channel that is producing this phosphine or not. And on the other hand, we do not know what type of bacteria, if it is biological, is producing or not. The first thing is also very complicated, that is the chemistry, the chemical thing, because the atmosphere of Venus is a very complicated. It has sulfuric acid, sulfide, and is a very little amount of oxygen, 0.002% of oxygen, and a huge amount of carbon dioxide. And after all, there is no magnetic field in Venus. You know that Earth has a magnetic field, dipole magnetic field, and because of that magnetic field, the charged particle from the solar wind cannot penetrate it. But in Venus, this convection inside it, convection of liquid iron or some such type of thing that produces the magnetic field is not there. It has stopped. And so there is no magnetic field. As a consequence, the charged particle from sun, the energetic charged particle, it penetrates in all direction, and it changes, it makes the chemical reaction. So if phosphine is there, it could have been dissociated by this charged particle, or even there is no ozone layer. So ultraviolet rays, energetic ultraviolet rays from the sun should have also destroyed it. So that means when phosphine is there, there is a continuous production of this phosphine. So what is this chemical channel? What is this unknown chemical process that can produce this phosphine? Nobody knows. This is the job of the chemist to find out that what other procedure can be. See, it may happen that in the laboratory we do not know. Like in the sun, there are many lines, absorption lines, which are called formidable line, which cannot be produced on Earth, but it is possible only on Earth, on sun. Now, if you come to the biology, then also the question will come. So, what type of bacteria that can survive such type of condition on that region where this bacteria, I mean, the phosphine is found, the temperature is reasonably well. It is not hostile. It is 60 degrees Celsius only. So, 60 degrees Celsius, even human can also survive for some time. The pressure is about 1 bar. That is whatever be the pressure, atmospheric pressure we have on the surface of Earth. But this region has a solid concentration of sulfuric acid, which is very coercive, which cannot, means life cannot survive, any form of life. And moreover of that, these charged particles are entering, the ultraviolet are entering. So what kind of bacteria that can survive and that can produce this phosphine? Now, if you think that, okay, the life there, the bacteria may be entirely different, its biochemistry will be entirely different, but in that case, it may not produce phosphine. So what bacteria, the kind of bacteria that is producing the phosphine on the Earth, exactly same type of bacteria should be there, or at least its biochemistry should be like that, so that it will produce the phosphine. Otherwise, it will produce something else. Why should it produce the same thing that the Earth-based bacteria is producing? Then, moreover, there will be another question whether this life, if it exists, if this phosphine is because of life, if it is really by bacteria, then when this bacteria was born, how it was born, or was it imported by some asteroid or something like that, and then how it is survived? So all these questions are now posed. Now, as Carl Sagan has told, that extraordinary claims require extraordinary evidences. Now, the group of astronomers who has reported this thing, they have never claimed any thing that there should be life. So they have not claimed any extraordinary, they have not made any extraordinary claim. But they told that there is phosphine and we do not know how this phosphine is formed. So there is a two possibility. One is unknown chemical reaction or a chemical process, or one is by life. So now these evidences doesn't satisfy Carl Sagan's criteria. So it is no way is an extraordinary evidences. Therefore, we need further evidences, further probe, further investigation to see what is actually happening in the atmosphere of Venus. I hope this answers all your questions. Still, if you have questions, you can ask me.
This puts in perspective for all of our viewers. Thank you, Professor Sujin Sen Gupta, as to what is the current excitement, what has been found, what can we infer from that finding, and now perhaps what is ahead of us. And now there are all of you children who are watching, and so you may have some idea. Maybe you have observed Venus, maybe you have not. If you want some help, we are here to make you Venus friendly to you. So we are going to show you how you are going to observe Venus in the sky. Any questions? We had a young child who had come into the planetarium, and he had this question.
The Mercury is the first planet, but why we are still saying that Venus is the hottest planet? Why?
So that was a few
Venus,
years ago. He had come
yes,
to the
very good question.
planetarium.
Although Venus is not the nearest planet in the solar system, Mercury is the nearest planet. Why Venus
Still, it
is
is
the
the
hottest planet?
hottest.
That is because Mercury doesn't have an atmosphere. It has only a solid surface like Moon. But Venus has a solid, gaseous, very dense atmosphere.
Atmosphere.
Now, what is happening in the early stage, Venus was cooler. But then, because of the presence of carbon dioxide, several acids, and many things, the solar radiation got trapped. And that warmed up the Venus like it has warmed up the Earth. This is called greenhouse effect. But in Venus atmosphere, it was so thick and so much carbon dioxide is there that there was a runaway, rapid and excessive greenhouse effect that increased the temperature to 460 degrees Celsius. So it is because of the thick atmosphere and the runaway greenhouse effect that made Venus so warm. Now here on the Earth, we have exactly the appropriate amount of carbon dioxide, water, nitrogen, etc. But if we the intelligent life, if the human being produces so much carbon dioxide through our industry, through our civilization, very soon Earth will also become warmer, 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 and who knows, one day there will be runaway greenhouse effect triggered out, and then the entire Earth atmosphere will become like Venus atmosphere. We all will die, and if extraterrestrial intelligence detect us, they will come and they will find phosphine, methane, everything, and they will tell who produces it. So they will be also wondering, like now we are wondering who produces this phosphine, how the phosphine was produced. So if we are not careful, we don't take the protection, we do not stop cutting the trees, we do not stop excess amount of carbon dioxide, then within 100 years, the Earth atmosphere may also become like Venus atmosphere, and then we all will be extinct, and leaving a trace of phosphine, methane, and all those type of things. So this Venus teaches us something, that don't play with nature.
So maybe some of you students have heard of this phosphine, this particular molecule, maybe for the first time. We have here Tripti, who is going to make you understand this, the chemistry of phosphine. There is a question here, and this is to both of you. Is presence of phosphine conclusive proof of life on Venus, or is it a
Already I
higher
have replied.
possibility?
Already I
Yes,
have
yes,
replied
yes. You
it. I
had
think you
already
have not
covered that.
listened it.
Yes,
Yeah.
you had covered that, and then yeah. And how does phosphine not get synthesized in any other way? Maybe if we have some discussion about the laboratory and the industry production of. So Tripti, would you just give a little bit of
I think
this introduction?
let me say the Priyodarshan Chaki. I know. I think you have entered after my lecture there.
Yes, yes. That is
As I
that
told
is true.
that phosphine needs a lot of energy, more than 550 degrees Celsius energy and tremendous pressure, which is not available in the rocky planet, and it is available in Jupiter and Saturn, in the deeper region of Jupiter and Saturn, and it comes out through convection, and the rate of convection, the rate of mixing is much higher than the rate of chemical reaction, and that's why we see phosphine in Jupiter and Saturn, but we don't see in Uranus and Neptune because the rate of circulation, rate of mixing is much lower, much slower than the chemical reaction. And as I have told that this discovery of phosphine is not, it doesn't satisfy the extraordinary evidences. So it is not conclusive evidences that Venus has life. That's what I have already told in a 10-minute lecture. Thank you.
Yes. And Trupti, maybe did you want to
in
mention
fact,
about the laboratory preparation of,
sure, ma'am.
and then just for the school kids who are there to get an idea about that, and maybe from there we go onwards further to talk about what may be happening on Venus.
In fact,
I'm just going
Professor
to yes.
Sengupta, he very crisply and very beautifully covered all the pertinent points related to the chemical aspects as well. And picking up from what he said, he mentioned that the structure of phosphine for the younger students is it is a tetrahedral molecule, and it is pH3. So this molecule combining a phosphorus atom with 3 hydrogen atoms requires a lot of temperature and a very strong pressure condition. And as sir said very emphatically, that such temperature and pressure conditions are not available on Venus. So the possibility that हम ये सोच सकते हैं that one phosphorus element is present and you might have a hydrogen element, and the 3 and the 4 of them can come together and form phosphine. That can come as a possibility, but that does not happen on the surface of Venus because the pressure and the temperature conditions are not adequate. Now, the laboratory methods for the preparation of phosphine basically involves elemental phosphorus, and when elemental phosphorus combines with sodium hydroxide. So when this reaction takes place in the laboratory, it produces sodium hypophosphite and phosphine gas is liberated. As ma'am is also showing in the video here. So if you take white phosphorus and to it you add sodium hydroxide, the eventual reaction leads to the production of phosphine, and it is very important to maintain an inert environment. So inert environment, because oxygen, if oxygen is present, it will immediately explode. Like sir said, that earth पे phosphine का होना is a little difficult because on earth we have an envelope of oxygen. On Venus we do not have that oxygen envelope. So for phosphine to be produced or for phosphine to stay stable, the atmosphere has to be inert. It should not have any oxygen components present in it, because if oxygen is present, it will immediately explode with phosphine. The very important point from here, which one can think, is that even if we have elemental phosphorus available on the surface of Venus, for a minute if we assume that, there is no possibility of having sodium hydroxide, because the Venus clouds are hyperacidic in nature. They have a lot of sulfuric acid, and they have the clouds environment is precisely acidic. So if at all there is any base, it would not exist, and thus the possibility of a base existing which may come in contact with elemental phosphorus to produce phosphine is completely ruled out. The second possibility, or the second way by which one produces phosphine in laboratory is by using calcium phosphide. So calcium phosphide, when reacts with an acid, can produce phosphine. So the reaction is basically Ca3P2, which is calcium phosphide. It may react with water, or it may react with HCl. As sir has already mentioned, we do not have water on Venus, and although the environment is acidic, the possibility of this reaction taking place is again negligible, because उसके लिए you will need calcium phosphide. How will you get calcium phosphide? If the temperature and the pressure conditions are not strong enough to to combine phosphorus and hydrogen and hydrogen and hydrogen together, you can't even think of the formation of a complex molecule like calcium phosphide. So that possibility is also ruled out. In fact, there was somebody said that can it be synthesized in any other way? So these are the two primary methods by which phosphine is synthesized. And so if none of these two ways are possible to take place, the only way possible is, or the only speculation, or the only possibility which we can think of, is that probably a life form is existing, and a life form is somehow somehow anaerobically, under anaerobic conditions, under non-oxygen conditions, making the formation of phosphine possible. So there is a lot of a lot of discussion going around it these days, primarily because the environment of Venus is acidic in nature. So, and it is very interesting, and you will appreciate it, that phosphine in itself is weakly acid, is weakly basic in nature. It is a weak base. So a weak base, existence of a weak base in an hyperacidic environment, is again a thing which one has to really one has to really think about, and one has to really give very concrete evidences to confirm that. And a lot of studies have gone into it. In fact, the whole discovery came into light because of a paper published in Nature a few days back. And in that paper published in Nature, they have mentioned that they did a lot of extensive studies on the photochemical reactions, because लोगों को लगा कि हो सकता है there may be some ions or maybe some radicals present which are combining photochemically in the surface to produce phosphine. So that was also ruled out. Meteorites collision producing phosphines has also been ruled out. Lightning causing the production of phosphine has also been ruled out. Volcanic eruptions also being ruled out, and sir has also mentioned all these points in his discussion. So I think the only the a very strong possibility which emerges, which of course has to be substantiated in the future as well. We need more concrete evidences, but and we have to look into what kind of bacteria is being able to do this. But yes, of course, a very strong possibility is that it may be because of the presence of some life form.
It seems like this is a win-win situation, in the sense that as we move forward now, first confirming the presence of phosphine and then trying to figure out where it is coming from. Either it is microbial life or it is some new chemistry. So either
Yes.
way, it seems a win-win for science.
Either way, it's a win-win. Definitely,
There's one correction is there. The paper is published in Nature Astronomy, not in Nature.
Astronomy. Yes, a Nature Astronomy. It's
Yeah,
astronomy.
it's
There
a
are some
Nature
more
Astronomy.
questions. So there was one question I had flashed earlier, this one. So this, was Venus always this hot? What causes a planet to have such atmospheres?
I think sir already answered that question.
That little boy was also asking why Venus
Yeah.
is so hot.
Venus was not this hot all the time. After the runaway greenhouse effect has happened, Venus has become that hot. So in the first question, I answered that thing, that what is runaway greenhouse effect? If the greenhouse effect become very active and very fast, then it is so effective that its temperature increases very high. So greenhouse effect is there in Earth, on Mars also. Greenhouse effect, but in Mars atmosphere is very thin, so greenhouse effect is not that effective. In Earth, it is the exact amount of greenhouse effect that made the mean temperature of Earth from minus 15 degrees Celsius to 15 degrees Celsius, that is 30 degree, it increases by the greenhouse effect. But in Venus, it has increased about 500 degrees Celsius, means without greenhouse effect, the temperature of Venus, if you consider, if you take into account its reflectivity, that is 70% of the sunlight gets reflected from the surface of Venus, then the Venus temperature would have been minus 70 degrees Celsius. But because of this greenhouse effect, the runaway greenhouse effect, the temperature become mean temperature has become 460 degree Celsius. So the atmosphere has drastically changed from whatever it was at the time of birth. And this all these things, your second question was how this atmosphere, this all this happened on how much energy it receives from the sun, its rotation, its chemical composition in the atmosphere, its thickness, and the thickness depends on its surface gravity, etc., etc. It's a very complicated chemistry and atmospheric physics that explains that why the atmosphere of planets differ from one to another. For example, the atmosphere of Mars is very thin because its surface gravity is very less. It is half the mass of Earth. So much of the thing has gone out. The second thing is that there is no magnetic field again on Mars. So ultraviolet ray dissociate water and carbon dioxide, and they evaporate and goes out into the space. Same thing has happened with Venus. Um, uh, it is now believed that at one time, long ago, Venus has plenty of water. The same mechanism, Earth got plenty of water. Some comet or some asteroid has delivered the water to this all these rocky planets. But because of the intense ultraviolet rays and the temperature, almost all the water has been evaporated. And right now, we have. It is not that there is not at all water. There are 0.002% of water is still present, which can oxidize this phosphine, and phosphine can also react with carbon dioxide, and there are plenty of carbon dioxides are there. But whatever be the thing is that either we are seeing an unknown chemistry. The two possibility are equal. One is that unknown chemistry. We do not know what is the chemistry. It is often found that the chemistry or something different is there. As you know that we discovered helium only in sun, not before we discovered it on Earth. So maybe we are going to discover some new chemistry from Venus atmosphere, as Venus atmosphere is very complicated, and the possibility, and until and unless we resolve this thing, so the possibility that it is created by microbe also remains. But if you consider that it is by biosignature, I will question that how that bacteria can survive under that sulfuric acid, intense sulfuric acid, under that temperature 60 degrees Celsius, under the intense ultraviolet rays, under the intense charged particle coming from the sun, how it survived. So has it mutated to get it survived? And if it is mutated, then why the hell it is producing phosphine like bacteria in Earth is producing the phosphine? It could have done something other chemical reaction. So as I have told you that phosphine is detected, it is very excited in both way, that either we are seeing new chemistry or we are seeing life. But this is not a an extraordinary evidence to tell that life, there is a, even to tell that there is a possibility of life. And I again quote Carl Sagan: extraordinary claims require extraordinary evidence, and
Definitely, yes, sir.
the presence of life outside Earth is an extraordinary incident.
Yes, yes.
Very,
Uh,
very beautifully put, sir. I mean, seriously, this I particularly, the when you said that Jupiter and other planets also had some phosphine, but there was never such a huge cry about it. I mean, it was
100
not.
times,
Yes,
100
sir.
times more phosphine in
More.
Jupiter and Saturn. So in Jupiter and Saturn, the abundance is part per million, and here
Where
it is
here we have
part
only
per
ppb,
billion.
parts per billion. Yes, sir.
Billion,
Yes, sir.
20 part per billion, and there it is a few part per million. So it is 100 times less in Venus.
Yes, sir.
But still we do not tell
Still,
because the atmosphere, when we know that Jupiter and Saturn is a very cold and they don't have a solid surface, they cannot have liquid
gaseous.
water. So all those things are there, and we know, as we get somewhat suspicious that some of the satellite of Jupiter and Saturn may have life under that. But then again, if there is a life, then those form of life we do not know also, because our knowledge on biology is limited to the Earth-based life only. So how they will
Yes.
survive without energy, without oxygen? Okay, the beginning in the Earth, when life formed, it was anoxygenic. So oxygen was not needed. It was survived by taking carbon dioxide. But then cyanobacteria started doing photosynthesis, and it changed the atmosphere of Earth, and it become
Oxygen.
oxygen rich. All type of thing are there. But if you see that the biochemistry or the composition of all life from amoeba to human being are same. There is a common biochemistry. There is a common composition, that is the organic material based on carbon. Now, if life exists in other form and other biology, we cannot recognize it as life unless and until it is an intelligent life and tell that, look, I am also life. In that case, we can prove that the laws of biology are not same everywhere. Although we know the laws of physics are same everywhere in the
Same
universe.
everywhere. That's
If you
true.
throw an apple, it will fall towards you in Earth. If you go to the corner of the universe and do the same thing, it will fall to you, because Newton's law is valid everywhere. Einstein law is valid everywhere. Faraday, Maxwell are valid everywhere. But we, unfortunately, we still do not know whether the laws of biology are same everywhere, because we know only life on this planet. We have not yet detected. Efforts are being on. I am one of the person who is for the last 2 decades are working on exoplanet, finding out the signature. And phosphine is that the phosphine is a signature, is a recent thing there. It was published in 2017. Actually, let me tell you that this detection of phosphine in Venus was actually discovered in 2017 by using a telescope called James Clerk Maxwell telescope in Hawaii, Mauna Kea. And then it was confirmed by using ALMA telescope,
Alma.
Atacama large millimeter telescope.
Millimeter. Yes.
And this line in phosphine is found in 1.123 millimeter. So it is in the millimeter range, and in the radio wave, it is this line is found. So observationally also, it is very sound evidence. They have got it. They have analyzed everything. And one of the co-author was my postdoctoral researcher 2 years ago, Sukrit Ranjan, who did his PhD from Harvard University. After doing PhD, he worked with me in IIA to do the similar type of thing to find out what more can be the biosignature of all those things. So I know this group very well, and they are the one of the best group on the earth that understand the planetary science very well. So when they tell that they have checked everything and they found that there is no known chemical process in Venus which can explain this phosphine, I believe it. But it is very difficult to believe that this is produced by life. So in one way, if you ask that how it is your feeling, my head is telling it is not, my heart is telling it is.
Also, Professor Sanjay Limaye's work has dwelt upon how it could be possible that maybe, I mean, they do exist. So I'll put in, I mean, I'll call in from him, from Professor Sanjay
And about
Limaye,
two
and then
years
we'll
ago,
continue.
we published a paper in astrobiology with the idea that, well, one of the problems about Venus was that even though we had been following the features that we see in the images, we see dark and light patches in the cloud cover, and it's through the tracking of those features that we realize the super rotation of the Venus atmosphere that was done by an amateur astronomer, Charles Boyer, in the 1960s. And even though we could follow the features, we didn't know what the features were due to. The clouds of Venus are very different from what we see on Earth. It's almost like looking at a gas giant planet. That is, all we see is cloud globally on Venus. There are no breaks. So when you see dark in these images, that doesn't mean that the atmosphere is clear. There is still cloud. It's just that there is no absorber there. So there's no difference in the properties of the bright patches and the dark patches, except in the amount of absorption taking place in the darker areas. And we didn't know what this absorption material is. And we still don't know what it is. So 2 years ago, we published a paper suggesting that perhaps, since none of the chemicals that had been proposed were able to explain the absorption, that it could be due to microorganisms. And that's the figure that you see on the screen right now. And we suggested that the clouds harbored some microorganisms which had absorption characteristics that mimic those of Venus. And this we discovered because some of the terrestrial bacteria that we find here, uh, especially ones such as Thiobacillus ferrooxidans, has an absorption spectrum that mimics that of Venus. And that was very surprising. The absorption peaks at about 370 nanometers for the bacteria and also for Venus. So that match allowed us to suggest this notion that if life evolved on Venus or originated on Venus, when Venus had liquid water in the past, it could have migrated to the clouds and resided there. And that suggestion, that paper, led to a lot of interest among the community, in the Venus community, and I convinced the Joint Science Definition Team for Russia's Venera D mission that a biogenic search for uh, life in the Venus clouds should be made for Venera D, and it's now been accepted as one of the science goals.
Okay, so Professor Nimai was talking about their speculation some time ago about the possibilities of how, under these extremely inhospitable conditions, how they are speculating that there is a possibility. Of course, this is um, because we have found this phosphine, so these questions will be more scrutinized. Now, these possibilities will become much more. I think Professor
Yeah,
Sengupta, you
I
wanted
means
to
no, no.
say
What
something.
I asked about
Say.
the wavelength, that he has told that 370 nanometer, but it is not clear to me that the absorption line is due to the bacteria or due to the product, some product that is due to some chemical that is produced by the bacteria. What was the prediction?
Okay, Professor Rimai, this is a recording which we have used. So we will, I mean, we perhaps would be continuing this discussion
I,
in
I didn't know that. Okay,
coming
I thought
sessions.
that he is also live. Anyway, I
No,
will
no,
see
no.
the
He's
record.
from he's in US, so this time isn't working out convenient. So I've taken a recording, and we'll continue this. There are several questions. In fact, although some of this has been addressed to some extent, but I thought you may want to still take this particular question which was there about which is right up your
I can't see.
universe
Where can we expect
pathway.
to find life on
This
other
has
exoplanets? Well, actually, right now we are searching in our galaxy according to our the technological capacity. Now there are two ways of that. I am one of the signatory of the Breakthrough Initiative, so that searches for intelligent life. So what they did, they do that. Yuri Milner, the billionaire CEO, Zuckerberg, and quite a few people, they have donated some money, $100 million and more than that. So using that money, the nights in the radio telescope or the times in the radio telescope has been bought, and they are trying to receive any artificial signal, any signal that has any pattern or anything. So that is the search for intelligent life, and that can be extended even beyond our galaxy. But my work is concerned on the biosignature on any type of life, whether intelligent or unintelligent, doesn't matter. But the biosignature means the biology that the life that produces the signal, like phosphine, like methane in oxidized atmosphere, like ozone or oxygen molecule. Those are the biosignature. Now the thing is that we are looking for a planet in other planetary system. We have already discovered, the astronomers, more than 4,000 planets, extrasolar planet. Some of and The diversity of this planet has completely revolutionized our idea. Some of the planets are even 10 times heavier than Jupiter. Some of the planets are very big Jupiter size gas planet, but they are very near to the star, so their temperature is so high that even gold can melt on their surface. And we have found rocky planets which are very near to their star. We found planets orbiting two stars. We found planet orbiting without any star. We have found diamond star, many type of planet we have found. but the one planet that may harbor life, or that is called the habitable planet, it has to be in the habitable zone of the star. The habitable zone means it should be at an exact distance from the star, so that its temperature should be appropriate for water to exist in liquid form. That is called habitable planet. Another condition is that to retain this liquid water, that planet has to be rocky. So it should have a rocky surface. It may happen that a rocky satellite around a gas giant planet at a distance at this habitable zone can also harbor life. But these are two minimum conditions. Now the Earth has several other conditions that has been protecting life. Even the presence of Moon is also supporting life. The presence of Jupiter outside are also protecting us from the collision of comets and giant comet collision type of thing. The magnetic field on the Earth is protecting, as I have told you, that it is preventing the charged particle to enter in the Earth atmosphere. It can only enter through the magnetic pole, and because of that, we see aurora borealis. Then even volcanoes and Earth plate tectonics are also protecting us, because the carbon dioxide in the Earth atmosphere, that plays double role. That is by reflecting sunlight and making the Earth cooler. At the same time, it is a good agent of greenhouse effect. So it is balancing the temperature of the Earth and maintaining the ambient temperature, so that water can stay in liquid form. Now, if this carbon dioxide mix up with rainwater, it forms a carbonic acid. The carbonic acid is a, I think, Tripti is now nodding the head, and chemistry is coming now. So this carbonic acid is a weak acid, so it falls on the rock and then combine with the silicon and form the silicon carbonate. This process, if it continues in 1 million years, then all the carbon dioxide would have mixed up on the Earth's surface, and the Earth would have become quite cool. But through the plate tectonic or earthquake or through volcanoes, this carbon dioxide is again coming out and rejoining the Earth atmosphere. In that way, in 10 million years, there is a carbon silicon cycle. Similarly, there is a nitrogen oxygen cycle, and many cycles are there, which is possible because of the Earth has a very active geology. And the minerals in the Earth has been reprocessed. That atmospheric composition is reprocessed because of tectonic. So these are the essential conditions that made here life not only to origin. We do not know how the life originated on Earth. Yeah, whether it is originated on Earth or whether it has been imported. The seed has been imported to Earth and then it got a good environment. But the a combination, a very rare coincidence of geological and astrophysical combination made life to survive here and to evolve into complex life, into human being, which can ask the question, is there anybody out or we are alone?
Okay, so coming back to Venus, actually, in that there is this question. Maybe there's a little bit of a confusion, but I thought this question will allow us to talk about life present and life past. The question between Venus and Mars. So, see, when Siddharth, when these videos, sometimes they may be from movies, etc., etc., and some of them may be speculative and so on. In fact,
I think you have seen a science fiction video
yes,
that has
yes, yes, yes.
given that.
There was one. I think which just about the time perhaps that Venera landed. There was one movie where all this was shown. So there was that confusion. However, he's asking whether the phosphine which is now being seen is from a billion or million years ago or present. So I thought that point we could
That we don't know.
discuss.
That we do not know,
Yes,
and it is very difficult to say that when this phosphine is formed. If the life, if it is a biological thing, if it is a chemical thing, it should have been there for a long time. That's a very subtle problem, that when this phosphine has been originated, or how long it is there in the phosphine.
Here is a question which will be very useful for discussion of which for students to know how exactly these things are being determined. All we get is just light, and even the largest telescope is only showing them as
What are the
points of light.
different methods to detect the chemical composition of the okay, so
Will be
so
good to discuss.
usually
Spectral
uh,
signature comes.
so these are why for exoplanet? Even for stars and
Yeah,
everything.
for
For
everything.
any
Everything.
planet, for any
Chemical
planet.
composition is known by sending the light through a spectrograph, and the spectrograph splits into different
Wavelengths and
color
frequencies.
associated with the wavelength. And in that spectrum, there are certain black vertical lines, which are the absorption lines with some particular wavelength. So, from seeing this spectrum, that dark vertical light, we can see that what is the composition, the chemical composition, or what is the abundance of that object. So similarly, for planetary case, it is somewhat complicated thing. So instead of direct because the planets are very small, it doesn't have their own light, and they are hidden in the brightness of the star. So what we do that we take transmission spectrum. So what is the transmission spectrum? That when the planet transit across the star, that is when the planet is in between you and the star, then certain amount of light from the star is blocked, but a minor amount of light passes through the atmosphere of the planet. And when you subtract it from the stellar spectrum, then we find out the residual as the planetary spectrum. So this is called transmission spectrum, and this transmission spectrum give us the information about the molecule, because the molecules cannot be present in star because the stars are very hot. The minimum temperature of a star is more than 1800 degrees Celsius, and luminosity is also very high. So molecule usually, even the coolest star have only two diatomic molecules. So diatomic molecules like methane, carbon dioxide cannot be formed in the outer region of the star. So once we get in the spectrum, the transmission spectrum, the signature of this type of molecule, we can tell that what are present in those type of planets. So in that way, we understand the composition of the atmosphere of. See, for even for star or planet or whatever be the thing, what we come to know about the atmosphere, then we extrapolate it to the inside and say that what is happening there. We cannot see inside the star or inside the planet, because there it is so thick, it is optically completely thick, and light doesn't come from here. See, the light takes million years from the center of the sun to come out there. What we are seeing that is a relay race type of kind. First, it is a radiative zone, there is a convective zone, then again there is a radiative zone. So, through different method, the light comes out. But when it comes out from the transparent region, from the atmosphere, it interacts with the matter present in the atmosphere, and that gives rise to those absorption line. And from that absorption line, just like a detective, we find out that what is the nature of that star or that planet.
Yeah, that's the way for the cosmic detectives to go. That's the cosmic detection story. And between like finding elements and finding molecules, let's say, in cosmic locations, we just shift in our wavelengths, right? So, in terms of.
So,
Yeah.
No, molecule in planet is found everywhere, even in not only in infrared, it is in the optical also. Water is found, alkaline material is also found in some of the hot planets. So, water, methane,
many
those are
new
present.
species also, sir, these days which don't exist on Earth are being found on all these planets. Very complicated ones also existing in these planets these days.
Yeah, that's the complicated thing. It depends on what was the initial condition, what was the initial composition, chemical composition of the star forming cloud, and what was left over. So it all varies from the nature of the star to nature. For example, the cloud out of which sun is produced has almost double the abundance of oxygen than carbon, and that's why the same material after forming the sun, whatever be the leftover, that has formed the planet. So the planet and the suns have the same chemical composition, but because that initial cloud has almost double oxygen, so we see in Earth's surface all oxidized, more oxidized, carbon dioxide, water, all type of thing. But suppose if the cloud has equal amount of carbon and oxygen, then instead of oxidized, we'll see all carbon type of thing. Most of the thing, even our rock, the surface, it will be made by carbon, coal. Now, if this planet is very near to its stars, then under that tremendous temperature, that surface can become diamond. On the other hand, if it is in the habitable zone, it is cooler. So in the deep region, under tremendous pressure and temperature, the entire mantle can become diamond. And if this life has some life, I mean, this planet has some life, it is a habitable planet. So they are very rich. Now you imagine, at least 3, 4 such type of carbon star and planet has been discovered. It's called diamond planet. So if there are hundred of diamond planets, then how rich is our galaxy? The only problem will be there how to extract those diamond.
Okay, and I was thinking the directions now ahead after this finding of phosphine, the its confirmation, and then from there moving to connecting it. So also some input from Professor Sanjay Limai I was going to put in and move onwards from there in this forward direction. Some very exciting possibilities from India. So we'll be talking about that too. And so I was
Question of
just putting
phosphine
in.
raises many questions. First of all, phosphine is not expected on the Venus at all because it's not a reducing atmosphere. It doesn't have hydrogen. You see phosphine on Jupiter and Saturn, but it's formed in the presence of hydrogen under deep, high pressures and high temperatures. You don't have that on Venus. Hydrogen is not that readily available because you have some moisture, not enough, because all the past water has evaporated away, and there's only a small amount in the clouds as vapor, and some is mixed in with the sulfuric acid in the droplets. So besides sulfuric acid, and which is not really a thick cloud like you might find in a fog bank or rain, the particles are actually quite far apart. The number densities are low. So not having enough oxygen makes it not very easy for phosphine to be produced. So that's why the phosphine abundance, even though it's like about something like 20 parts per billion, it's still a low amount, but large in terms of, if you compare it to some other objects. So is it real is the first question. And the second question that follows is, where does it come from? Is it due to chemistry on the surface in the lower atmosphere, or is it due to life? So there are many questions that we don't know yet.
And in this direction, there is the Indian mission, Shukrayan, mission to Venus. And there is a planned payload on this, which may actually go to Venus and then explore further this presence of phosphine. So I was going to bring in inputs from Professor Umesh Kadane, IIST Thiruvananthapuram. But I think Professor Sujan Sengupta, you had something to comment from the previous.
Yeah. I think that is the most important outcome of this result of phosphine. That now NASA, now ISRO, now the Russian, they should be very serious. They should be very generous, the government, to make these probes, because now the only way to resolve this issue is to send a orbiter, and then subsequently, like our ISRO's Sukrajan has some proposal that send a drone or a balloon in that region and then collect some data and do the immediate chemical testing as we do in the Mars surface, like that. So a drone can be. So now it is the action time. So this has the excitement has begun now. This is just the beginning of the actual excitement, because in
Yes,
any
yes.
way either we are going to discover a new chemistry or we are going to discover life. But now the next step has to be, it must be, to send as many probe as possible by various countries and with collaboration, in collaboration. And then not only is the orbiter, not only the lander, well, let us send a drone or a
There
balloon
is a
into that region and get a
net
direct
connectivity issue, I think.
reading.
Let's
Yes.
hear from Professor Kadani. I think there is a connectivity issue. Okay.
So, good afternoon. This is in the context of recent news and a recent publication uh, indicating the detection of phosphine gas in very trace quantity, parts per million level, But this measurement was done on ground using the radio waves, the radio telescopes. So it's a very interesting discovery, and if you get into the details of the work, it's a very nice work with a very thorough analysis, and they have taken care of all the noises and all sorts of possible contaminations. But having said that, this measurement was done with one particular transition from phosphine gas and in a very trace quantity. So this has initiated more questions than it has answered. So now we have to figure out, are there other transitions which can confirm the presence? So people, I'm sure, will be planning radio telescopic measurements and observations quickly to confirm this. If these are possibilities, those experts are very different categories, so I can't comment whether it is even possible, but definitely people would be looking. The second possibility is to find out whether it really means biological life. So far, whatever we have understood, the origin indicates that it is possibly biological. But now that we have an evidence that such a gas exists, so it is more important now to focus on laboratory investigations, both in favor of this theory and pointing out whether there are alternative non-biological origins. So there will be a lot of research now on that areas. Also, already a lot of work has been done, and now there will be more focused work on that. But the best thing would be to go there and actually do the measurements. But it's not so easy to go to Venus. It is closer to Sun, has higher heat flux. The atmosphere is, as you know, very dense and very hazardous, acidic. So making measurements in Venus atmosphere is a very challenging task. First, you have to go there. Going to another planet itself is a challenging task. So many countries have attempted it, and many results have already been obtained. But as of now, I think there is only one mission which is right now circling around Venus at about 1,000 kilometers height. But we need to go closer when we want to really investigate these kind of emissions or gases. So it would be nice to go closer, say a few hundred kilometers height. So India was already planning for the next mission to Venus. It is planned that it will reach there by 2023. So preparations are going on, planning, designing, and choosing the instruments. IIST, we also proposed from IIST one instrument in collaboration with PRL, SPL, and Kannur University. We have jointly proposed a small instrument. We prepared a similar instrument last year and launched around Earth to make sure that we know what to do and how to work with the instrument, and that instrument worked very beautifully, and that instrument was built by our students and it worked very fine. So now we are just upgrading that instrument and preparing it for the next Venus mission. It's called the retarding potential analyzer. It measures basically the ion and electron density in the outer part of the atmosphere of the planet, where the solar radiation meets a very low density atmosphere and ionizes the gases there. So you can actually detect them in situ. So these kind of in situ measurements are very, very useful. This particular mass, which is mass 34, is very much in the capability of our instruments. If it is there, if it is escaping out of the atmosphere and getting ionized in the presence of sunlight, we will see the signatures of this gas. So we were anyway planning to study other gases there, like oxygen and carbon dioxide and so on. So we expect that this instrument will be able to detect phosphine also, but it's a possibility. We have to now discuss with our collaborators and make a concrete plan if such a thing is really possible. But definitely it is a great opportunity and it's a great time to initiate such.
That's really wonderful. We have a mission planned, and some of can be tweaked to address this question which has come up, new question which has come up. And students, I mean, this is something for you to know, that India's mission to Venus can address this question further now, in terms of how much is there and what does it mean and so on. So I'm just checking. I'll leave it to both of you to move it forward. I'm just checking for student questions. Perhaps some of them will come into the studio. I'll be coordinating that. If you could move the discussion forward, meanwhile.
No, I think almost everything is said. Whatever we know very little. So let us now have the question.
Yeah,
Let's see the
yeah,
question.
yeah, yeah. I'll just actually all the things which I had planned to share with you, students, which was simply to do with basically just Venus and some properties of it, some very very interesting aspects of it. I haven't done that, but I thought the questions were more important. So let me still, yeah, there is a question which has come up to Tripti. You, mm, yes. So the question, yes, says that about the tetrahedral
Okay,
Venus
so
structure.
the lifetime as such is very, very small. I think, if I am not wrong, I read about it somewhere that the lifetime of in fact, in the paper in Nature Astronomy, it was mentioned it has a lifetime some few seconds, some 10 to the power some seconds. I'll just cross check it in the meanwhile. Its stability is all the more in question because of the acidic environments. So as I told you earlier that Venus, that phosphine is mostly a weakly base. It is a weak base. It is a Lewis base. So it's a weak base in nature. So an existence of a weak base in a primarily acidic environment is itself a question to be discussed. And as everyone has been, like all the senior scientists have been asserting the fact that this is just a possibility, and more and more research has to go into this in order to confirm that yes, the signatures that we are getting are from phosphine, in order to confirm b that it is a new chemical reaction which is generating it, or in order to confirm c that it is a new bioorganism, a microbe, or any new organism for that matter, a microorganism that is allowing for the production of this phosphine gas. But I will exactly give you, in the meanwhile, I'll just find out the timing, because I did read about it in the paper. In the meanwhile, sir, could you please continue in from here?
Yeah. Yes, and there are a few. I think there is one additional small input which Professor Kadane was also wanting to make in addition to the current phase of opportunity. So maybe we would include that as well.
Yes,
So let me do that.
ma'am, can I just interrupt? So,
Yes.
in this paper, it says the lifetime above 80 kilometer on Venus, which is in the mesosphere, is is less than 1,000 seconds. So that is about the lifetime, because you wanted to know how stable it is. So it only exists for less than 1,000 seconds. So you can understand. I mean, 60 seconds is 1 minute. So how long is the molecule existing, and that too in the upper atmosphere, somewhere in the mesosphere, 80 kilometers and beyond.
So you wish to
And
add with this?
and the paper also says that near the atmosphere's base, the estimated lifetime is 10 to the power 8 seconds. So 10 to the power 8 seconds around the atmosphere, I mean, towards the lower atmosphere, and 10 to the power 3 seconds less than 10 to the power 3 seconds in the higher atmosphere. So that is the stability, not in particular very stable. That's not the case. Very small lifetimes.
There, there are
Sir,
a
would
few.
you like to add there to it, Professor Sengupta? Sir, please,
No,
could
no.
you please
I
add?
mean, I hope that whoever question is not meaning the radioactive lifetimes. The,
No, it
it's a
says
chemical lifetime, right?
yes, sir, it's a chemical lifetime,
Yes.
Yeah, in this context.
because it says that the lifetime of phosphine on Earth will be much longer, whereas that on Venus is not. It says the lifetime of phosphine on Venus is key for understanding its accumulations. This lifetime will be much longer on Earth, the atmosphere of which contains substantial molecular oxygen, whereas on the lifetime on Venus above 80 kilometers is predicted by models to be less than 1,000 seconds, primarily due to high concentrations of other radicals.
Would
And
this
not only
also
the
get
high molecules, not only the high molecules, there are, unlike the Earth, there are charged particles from sun, there are ultraviolet rays, many
Yes,
things are
yes.
there.
So all these
Uh,
radicals
yeah,
and reactive species may
that
combine with it,
reduces,
and
yeah,
yes.
that reduces the lifetime, the stability. Actually, we should not tell it lifetime, we should tell the chemical stability of this compound, much less than what it is in Earth.
And of
and
course,
this
because
would
it is basic in nature, so obviously its stability will not be it will not be very stable in a highly acidic environment, is what, if Siddharth, that answers your question.
would this would also get connected to, I mean, thinking about the two possibilities, whether maybe back in history sometime there was some microbial life and then phosphine is still a signature of that life, or there is
No,
continuous
no, no, no,
production.
no,
This
no,
would
no.
get
That's
related
the
or no?
thing.
This would
Yeah,
not.
if that is the case, once upon a time it was there, then all the phosphine would have been destroyed. So now, why this inequilibrium? That there is a continuous pumping of this phosphine. So because of that, we are seeing the excess thing. The phosphine,
Yes,
whatever be the
yes,
thing, it will be destroyed. It can't last for more than 2000 second or whatever she is telling that.
yes, yes,
So
yes, yes.
that's why when it is detected, that means there is a continuous source present which is pumping, like in the Jupiter. It is actually from inside the surface, but then by circulation, by convection, it is coming out. Now, as soon as it's come out, it can be oxidized. But why we are still seeing? Because the rate of chemical reaction is much slower than the rate of circulation, the mixing up. So here also the same thing. The rate of destruction of that thing is slower than the rate of production, and that's why we are seeing it.
So unlike the
Ma'am,
methane as a
Ratna,
biomarker, this, yes, yes, please.
Ratna ma'am, can I just share my screen to show that paper
Yeah,
from
go
which I
ahead.
am?
Please, please go ahead. Go ahead.
I'll
Yeah,
just
I have a copy also, but you go ahead and share the screen. And meanwhile, I'm also checking for other possible questions. And it seems like methane as a biomarker
Ma'am, is the screen visible? Is the screen
and
visible now?
phosphine. Yes, yes, yes. It is
So
visible.
this is the paper that we are all talking about. The paper about the phosphine gas in the cloud decks of Venus, which is a paper in Nature Astronomy, and it's been published on the 14th of September. So it is in this paper that that I've read about this, that the lifetime of phosphine on Venus is for key understanding, and this lifetime will be much longer on Earth because phosphine is stabler on Earth because the environment is congenial, whereas the lifetime above 80 kilometers on Venus is as predicted by models is less than 1000 seconds, primarily due to high concentrations of radicals that destroy phosphine, that react with phosphine and destroy it, because phosphine is a highly reactive molecule.
Chemicals. Yeah.
So
Yeah, that's right. So that's why you need continuous pumping production of phosphine. Otherwise, you won't see it there. So
yes, yes.
that means that either this bacteria or whatever, whoever is doing it is still alive, or
Huh.
the chemical reaction is continuous process.
Continuously happening.
And we were discussing about going to Venus, and in that context, there was a small additional input which Professor Kadane had. I had not made it earlier. Let me put that in, and then we will
There was a
move
question
forward.
on methane,
Professor.
I think you
Yes,
told.
yes. No, no, no,
What
no,
was the
no.
question?
I was just reflecting, saying that methane as a biomarker seemed to have said that it's possible even million years back, whereas
Methane,
phosphine as a
no, no.
biomarker is saying it's now.
No, I think your information is incomplete. Methane in a oxygen-rich atmosphere is a biosignature. If there
Huh,
is
huh, huh.
no
Yes,
oxygen,
yes,
then
yes.
methane can be produced chemically, like Mars.
Yeah,
But if methane is in a oxygen, so it reacts with oxygen and immediately become carbon dioxide and water. But if still methane is there, that means there is a continuous production, and that comes from the dissociation of organic material.
yeah, yeah. Yes, yes, yes. No, I was just comparing between Mars and Venus. Just it was just a thought, and I think I will go ahead and right now.
Just to add
Yeah,
a very important point, as it appears now that life related molecules seem to be at more places than we originally expected. Many planets, mini planets, as well as moons of planets also seem to have lots of interesting biologically, possibly biologically connected molecules. So more investigation of this nature is definitely warranted at this stage when we are expanding our space infrastructure to go to other planets and other celestial bodies. A lot of research activity is going to pick up now. So it's a fantastic time to invest time and efforts in this area. Thank you.
Yeah, and
Well,
actually, yeah, we
may I
actually,
interrupt here? So,
yes, yes, please.
no, unfortunately, from no other planet, biosignature is detected in the solar system, let alone the exoplanet. So,
But
this is the first time biosignature is found in Venus. In Mars, there was claim and counterclaim about methane. Further research is needed. Even our Mangalajan also went with a methane spectrograph but could not detect it. So methane is yet to be detected. But no, in planets or in satellite, any bio signature or biomolecule has been found. This is the first time something we
yes,
found.
yes. But speculations for Europa subsurface possibilities, etc.
Speculation is
So there are both
speculation. So there is no
speculation. Yes,
scientific
yes.
justification.
Ha, ha, ha. But these are all the
Said
direct
extraordinary. Carl Sagan said extraordinary
Claims
discoveries
require
need
extraordinary
extraordinary
evidence.
proofs.
Yes.
Yeah, yeah, yeah.
And
It's
he
just
is the
that
person
these are directions still to go.
and he is the person who predicted that there could be life in the cloud in the atmosphere of life in 1967.
We are
Yes,
just going
I see
forward.
that
I
another
think it is
question has
food
come.
for thought.
Yes. So he made
Yeah,
the
yeah, next
prediction
question.
out of the condition at that time known to him about the atmospheric condition. So on that basis, he predicted it. At that time, whatever was known about Venus, so Venera and other satellite landed at that time. So whatever he information on that basis, he predicted it. It was published in some September, I think, 1967. That paper is published where he predicted. I think now everybody will tell that I have predicted, but it dates back to that guy Carl Sagan, and I
No,
consider I am a
but
very big
yeah,
fan of Carl Sagan actually.
there are, yeah, so there are a good number of groups who have been consistently saying for now for some time, and including Professor Limai's group and
Yeah,
few others. This question actually,
there is
like
a if
we can also
phosphine
take
was
opportunity
produced
to
as
clear
a
confusion about the temperature on surface and temperature in the clouds.
Yes.
hmm. Now, what is the question there? Let me read it. If phosphine
Yes,
was produced as a result of organic reaction, will it be lost?
signs of life on Venus. As surface
But the
temperature is very
surface
high.
temperature is not very high, is it? It is not
I
very high.
think
It is
Eva,
only 60 degrees.
The
I
surface
think
surface is
Eva,
high.
Yes, surface.
Cloud temperature is lower.
I think
Yeah,
Eva
yeah.
has
Please,
joined
please.
just now. A lot of discussion has been done on that. The surface temperature of the planet of Mars is about 460 degree Celsius. No, Earth-based life cannot survive. Even no life can survive there. But where the phosphine is discovered, the temperature is about 60 degrees Celsius. But that is not the only condition. Even the pressure is also 1 bar, like normal pressure. You feel it. The thing is that what we have been discussing, what Tripti is also told, that there is a sulfuric acid. So you just put your sulfuric acid somewhere, you know that what will be the thing. You need not do anything. So
Highly corrosive. Highly corrosive.
how highly corrosive, and it can destroy any organic material there. So how it survived? Then there is another thing. There is no oxygen, so it cannot be oxygenic life. And then it has to be protected. It means has some capacity to be protected from ultraviolet rays from the sun, because there is no ozone layer. Ultraviolet rays entering into the atmosphere, and there is no magnetic field, charge particles. So there are many conditions. So although temperature and pressure is not hostile in this region, but the other conditions are very dangerous. Means
And as sir mentioned, the bacteria, if at all it is life, it has to be highly evolved to protect itself from
yes,
ultraviolet,
it
to
has to
protect
be.
itself from. It is a highly
So
evolved
some of the
bacteria. So we
extremo,
really have to
some of
study.
yeah, some of the extremophiles on Earth has that capacity to stay there, but they mutated with that, so it has to be mutated. But then it will bring the question that at what time it mutated, how it adjusted, how it is floating, why
And
it
why
is
is
not
it synthesizing only phosphine? Why only phosphine? Why not
exactly. Why not
oxygen? Why
methane?
not oxygen? Yeah.
Why not methane?
Hmm. Hmm. And perhaps, I mean, this now the mission which is going to Venus may look at all these other chemistries also and whether they kind of agree with this. So, in terms of further directions,
One thing I can confidently tell, I have full confidence on this group because I know Sarah Segar very well. I know Greaves also, the lead author, and one of my postdocs, as I told, that the observation is solid. Whatever they got it, they have verified in this ALMA. ALMA is, that world-based telescope in millimeter telescope. So there is no question that there is no line or detection. The question
Sir,
is
and
now
particularly to observe it in such trivial concentration is commendable. I mean, 20 parts per billion is
exactly,
actually nothing.
exactly.
Is nothing, and
Exactly,
getting it from a planet so far away from us, it's such
exactly.
a
That is
small
one.
concentration, and
Yes,
finding
sitting
out
on
of
the
it
earth.
is
Yes, sitting on the earth, detecting it. This has taken a decade for Greaves. Greaves is actually she is from Cardiff University. She is the leader of this project. So
that's commendable work, sir. Commendable work by the
hmm.
team.
But I'm
very
also very much
hopeful.
fascinated that this is a female power. Greaves is a female. Sarah Segar was there. You two are female. Among that, I am the odd person. So this exoplanet, planet, and life has attracted a lot of females, which are not seen in physics in general.
Women. Women. Yes, and so now we are poised with this thing which has happened. Maybe some further directions we have discussed quite a bit about what are the further directions. There was one segment I am slightly confused whether I played the segment or not because of some name confusions. I'll still play further directions, some inputs given by Professor Limay, and we may then be concluding if there are no further questions after that. So I just, I mean, many would have followed this and immediately jumped to the conclusion, oh my god, this news is telling us microbes. So thanks for clarifying all of that. And yet the direction seems to be that it must be pointing to something like this. Except that it needs further confirmation. It needs further
It
confirmation.
it certainly needs confirmation, and I think some of the questions may be partially answered by experiments on Earth by conducting experiments in the laboratory. Can you produce
Yeah.
phosphine artificially, or
Yes.
even looking at are there bacteria that can produce phosphine? That's not known.
Yes. Yes.
I mean, you
Yes.
can, it's pH 3. I mean, so far the wisdom was that it's found in decaying matter. So life is involved. But in this case, the question is the phosphine being produced continuously? That's a separate story, because if you have decaying life, either life must be regenerating to create phosphine from its dead matter, or life itself is producing phosphine. So there are two separate questions. I mean, for example, the island of Nauru is known for huge supply of phosphates. Now, initially it was thought that phosphate deposits was made by bird droppings in the middle of the Pacific. Now we know that that was not true. Yes, there are bird droppings that have phosphates, but most of the phosphate actually came from volcanic eruptions and interaction with the seawater. But nevertheless, it is true that fecal matter does produce phosphine. But until recently, there wasn't much discussion of phosphine being produced by life directly, living creatures. So there's a subtle difference here. Are we talking about extant life or dead life? Because when you go to Mars, nobody's talking about
Yeah, yeah.
life being present there now. You're still looking
We're going.
at past life or the fossils or something there. Maybe life on Mars, I don't know, but it's probably subsurface. So the situation with on Venus is a little bit different. I mean, if it is life, then it means life is there now, and that's a
Oops. Okay. So yeah, I mean some of these points have been discussed, but there was these inputs have been taken. I
Some dead
wanted to
matter
put
also,
them.
dead matter also releasing phosphine is also a hypothesis. So that is what Professor Limai was talking about. That maybe the
I wanted
phosphine, which
to note that.
is coming from dead matter or coming from live matter, live organisms. It's all under big question mark now.
I see there are many questions now. So let me just check what the questions are, and we probably were moving towards conclusion. And okay, so there's
I
something
think
about how we can encourage young children. Is there any courses for BSc, MScs? So these questions will take up in subsequent sessions. So somebody wants to know if there's an astrobiology course coming up, and something about somebody said quantum biology, and so on. So these aspects I think we're going to take up in other sessions. Is there any specific Venus questions I have left out? If I have left out, I would just suggest to the viewers post it again, because
no, I
I may
guess
have missed it.
we've
And we
covered.
are moving towards conclusion of the session now. So maybe I mean concluding comments from Professor Sujan Sen Gupta, from Tripti ma'am. And meanwhile, I'll keep checking if there are any questions Venus related. So Sujan,
Yeah, let's
we are
first take
going to conclude the sessions now.
Tripti first.
Tripti?
Uh, for me, it was an absolutely enlightening session to learn from Sir and to learn from you, of course, ma'am. And just to wrap up things crisply from the chemist point of a view, I say either way, even if it is the discovery of a new synthesis by which phosphine can be formed, we are in a happy situation. And even if it is a new organism which is creating phosphine, we are in a happy situation. Since the environment is mostly oxidizing, the existence of hydrogen and the formation of phosphine by lightning, meteors, volcanic eruptions, and all other possible methods has been completely ruled out. So these are the only few possibilities we are looking at. But yes, it's a long way ahead, and we have to do a lot of serious work in this, and a lot of missions need to be and I mean the various nations should invest into it, and a lot of missions have to be taken up. A lot of research in vitro and in laboratories has to be taken up in the favor and in against of this theory which has come up. And only then, maybe in due course of time, we will be able to completely say with certainty whether yes or no, and what are we looking at. So I would like to conclude just by saying that, and by thanking Professor Sengupta and Professor Ratnashri, and of course the planetarium, for arranging a wonderful session and for having me here to give my inputs as a budding chemist. Thank you.
Thank you, Tripti.
Okay, so
Sujan?
now it is my turn. I to thanks Ratna for this
Thanks to
invitation
both
and
of you.
for this outstanding session. I could not even realize how 1.5 hours has passed. And
Yeah,
no doubt I have learned many things from Tripti also. Chemistry was a subject which I was very much scared in my college and university. You may know that I actually did up to my MSc on mathematics and then switched over to
Oh,
physics and did my PhD in physics. And I worked for a few years in with NASA's fellowship also. Now also I am collaborating with NASA. In fact, yesterday night up to 2:30, we were discussing with my collaborators in AIMS NASA about the possibility about the presence of phosphine in Uranus and Neptune. And then he called some of the people, and the discussion went up to 3 o'clock. So today I really got up into that. Nevertheless, I mean, life is just a learning thing there. Every day we are learning it. So it's very nice to have a session with a chemist in that way, the person who has expertise on chemist. So the conclusion, as I've already told it, that giving all type of situation prevailing on the atmosphere of Venus, my head tells that it is not life, but my heart tells that it should be. It should be.
So we still
Thank
have a
you.
lot of detecting to go ahead, and so we will be alert and try to bring all those excitements to you. And there was somebody was mentioning that they wanted for much younger children and so on. We promised to take you on a trip to Venus. I had a lot of visuals put up, which I'll share in another session. Every Monday we have doorstep astronomy sessions, and today we had to go a little in higher because there is an excitement about Venus, so we had to bring that excitement to you. We had a session on Moon earlier, so we are going to have sessions for younger children also. And I want to thank the panel who have been here, who made us this trip to Venus for us so exciting. Professor Sujan Sen Gupta and Dr. Tripti Kumari, and we hope to have you more and learn from here the chemistry of exoplanets. So we will have you both for us to have a discussion of that. So thank you to all the viewers. We are going to be concluding this session now.
Thank you
And
all.
I was just checking. There are no other questions right now. I think so. We will be ending this broadcast.
I would
Thank you.
also like to connect with Professor Singh Gupta later
Sure,
on.
sure.
His sessions are so informative.
Yes, yes,
So,
yes.
sir, I am one of your followers now. Please let me know how to get to listen to more of your sessions.
Yeah,
We will
sure.
we will
Thank you.
have more.
You connect with me through Facebook, through mail. I
I
have
can
a very
I'll
active Facebook
surely.
account.
Okay, sir. I will.
Already quite a few webinar I have given, both in English and in Bengali for Bangladesh. And uh, so I think my next term to give for ISRO only. Uh,
I sure will
my
connect with you, sir.
my
Thank you.
colleague at this Isaac has invited me to give a on exoplanet. So connect with me in Facebook so that you will all know that activity of that.
So
And
we
thank
will
you,
Thank
be
you.
very
Ratna